Welcome to another GCBASIC demonstration. This one is specific around the AVRDx support that's been added to GCBASIC in August 2024. So I'll go into what AVRDx is in a moment, but essentially this is a new capability giving you full access to this vast range of AVR chips. AVRDx microcontrollers are 8-bit microcontrollers, were developed by Atmel. They're now part of Microchip, quite clearly, and they're known for high performance, low power, ease of use, and making them ideal for a large range of applications. So they're used across consumer electronics, automation, and automotive. And I've given you some words in why these are quite clever, because they're RISC-based, the same as the others, but essentially they've got very low power, integrated peripherals, flash memory, and now that you can do it in GCBASIC, it makes it so fast to develop. So we have developed AVRDx within the compiler and the tool chain just to be the same as all the old AVRs, PICs and LGTs. So you have direct pin configuration, that's direct and precision control over the microcontroller I/O pins. You've got advanced language features, which means that you can use assembly directly within GCBASIC, talking directly to these new chips. We've integrated that into the GC Studio environment, so you can write, compile, and you can debug in external tools. And obviously we've got a large community and lots of documentation to help you get up and running. So I'm going to show you some demos. I'm going to use a tiny 3217 and an AVR 128 DA48. Just flash some LEDs, and we're just going to compare that to doing it with an Uno. So let's get into it. I'm going to show you some boards here. I've got them on the desk here, but this is what they look like. They're little, what are they called? Curiosity boards. And obviously the tool chain supports programming these, and we'll have to look at how we do that. Let me go straight out to my desk cam. So these are a series of AVRs I have received. Some of them, I'm not joking. Some of these are 2 years old. I just hadn't got to them essentially. Such a backlog of work. I'm just going through here looking for the one I'm interested in. 3217, and this must be the 128. See, no. And over here, I've got a trusty Uno, look, okay? So look, if I look at the Uno, hey, why don't we do the Uno first? No, we shouldn't do that. We should, let me just zoom in on that a little bit. I'll just zoom in on that a little bit, and then we'll just hook that up and see what happens, hey? So look, that is an Uno, and we all know that the Uno has an LED on it that we can actually program. So let me just hook that up. I haven't sort of practiced this video, so I'm going to do it live. Here we go. I'm going to, oh, look at that, rotate. It will sit how it sits, if that makes sense. So what I've got is no LED flashing, and what I'm going to do, I'm going to go out to GC Studio. If it's not already running, probably is running already, and then we'll see what happens. We're going to make that flash. This is my screen, and here's my editor here. So essentially, I've given you a lot of demos, 128 mega 4809, tiny 4 and 6, tiny 1637, and a tiny 3217. All there, you can just use them. But what I'm going to do is I'm going to cut one live, okay? Which means I'm going to make a program. Control R will just bring up my previous samples, and here we go. I'm going to delete that. I have got an empty editor. I'm going to add in a mega 328p 16 megahertz, because that's what those things run at. That is conventional. This is legacy. This is legacy, so it works fine. I'm going to put a do loop in. I'm going to put a pulse out. How do we do pulse out? It's got some pulse. It would be a good idea if I spelled it correctly. Pulse out. It's port B.5 for 100 milliseconds. It helps me do that. Wait 100 milliseconds. Okay, so I've written a piece of code. I've just pressed function key F6 and it has compiled it. Compiler build version is 1406 for those following along at home. So what I'm going to do is program that. And to do that, I'm actually going to enter one of the menus. I'm going to start my preferences editor by typing in prefs. And I'm just going to make sure that my, I'll do it properly, prefs. And it brings up a dialog box and I'll just I'll zoom in on that for you so you can see it. Essentially, I've got an Uno at the top and I'm just going to edit the settings to make sure I've got it plugged into COM11. It says I'm on COM11. Fine, I don't care. If you go back to the zoom, where we were, I'm going to press this icon HF at the top. There's many different ways of pressing this HF. You can press function key F5, does exactly the same. So what's happening now, it's actually programming it. And out there we can see we have an LED that's now flashing. So somehow we've managed to make that flash, and we've done that quite clearly with that program. And you can see it there, look, it's flashing. I found a view here, and if I change that to Control C, Control H, I'm just going to change that to 1 second, replace that, and then press function key F5. It will reprogram it, and it will make it then flash every second. Great. That is a very simple program, but why just we do the same in AVRDx? So AVRDx, did I open the box for 32 nano? It's here. No, I didn't. Let me open it up. Here's a 32 nano, C nano. And I'm just going to plug it in. Now, C nanos are they support drag and drop. So let me just get that on there somehow. There we go. And it's just opened up a folder. It's the J folder. It's just opened it up. Doesn't really matter what it's doing because we are going to program it. Okay, let's go back to our source code. And I'm just going to change that to a tiny 3217. I don't know what frequency it runs at, so I won't put the frequency in there. And currently the LED is flashing, as you can see. So I'm not going to change the rest of the program. What I am going to do is change my programmer. So I'm going to edit my preferences. And I'm just going to drag, I'll zoom in for you. Just going to drag my C Nano USB to the top. And there's priority to this, but I'm not going to go into that. Just put it at the top. Now I'm just going to zoom out. Or I'll go into Zen mode, it's called here, there's Zen mode, look cool. I'm going to press this icon here, which is make hex and flash. It compiles it for the AVRDx chip. And the code is very different inside, but the high-level language is the same. It's just downloading it there. Now, sometimes on my computer, because I have a lot of shares, it's very slow. And this is one of those occasions. Because if we actually look at the folder, the file hasn't arrived, and it's meant to automatically do it. So I'm just going to do that again. And it's done it. Now, what I failed to do is change the port, of course, because the port's different. Now, do we know what that's attached to? On here, it says PA3. So I'll zoom in on that for you. I'm going to change the code to A.3. Function key F5, and it's compiling it. It's downloaded it already, and now you can see that that is flashing. It's done its work. It's really quite simple. If you don't believe me, I will revert. I will come back to that. I'll put the other big board in, and we'll have a look at that. So that's flashing. I'm just opening up another box, another board. This one's the AVR 48, and the LED is on. Looks like C6 to me. It's flashing. So over in my program, I'm going to type in the chip name. I believe that's correct. Let me just check that chip name is correct. AVR 128DA48 it is. I said it was on C dot something, C.6, I believe. C6. It's currently flashing. I'm going to change that to 100 milliseconds because it looks like a 1 second delay at the moment. So I'll change that to 100 milliseconds. Press the button for hex and flash. It's done it, and now it's flashing at 100 milliseconds. Does it actually zoom in any closer? Now, there's loads of demos. I've put up quite a few demos up for you, so you can have a look. Let's change the program. Let's do this. Port C.6 equals not port C.6. Now that will just toggle the port and wait 100 milliseconds, exactly the same, but I'm just going to I'm going to add in the direction. I need to set the direction using pulse out automatically sets the direction. So what have we got? The chip, port C.6, setting it to out, which essentially sets the out the registers correctly, and then I'm going to toggle that port. Port C, I'm going to program it, and we'll see that it's done it. And the problem is, it's hard to see when it's so fast. Downloading the program. This is my server at the back end. It's doing a search to try and find some files, and so someone can look into that for me. I'd be eternally grateful to find out why this little download program fails. It doesn't fail, it just takes a long time to move the file. That's what I did there, look, see? I just killed it by using there we go. Oh, has it done it? Done. Now it's every half a second. So if someone's got some time that can help me fix that problem, we've actually got a more sophisticated demonstration. Let's have a look at demo 5. Demo 5, what it's going to do, it's going to test the port.pin, it's going to do some clever stuff, but all it's going to do is set the LED to the state of the switch. And this is an input test and an output test. So if I quickly compile that, it's going to download that into the chip. Now, whilst that's starting, what I want to do is quickly show you Microchip Studio. So if someone look into this problem for me, please, I'd be eternally grateful. because it sometimes takes a millisecond, and another time it's just not copying the file every time. It does eventually get there, it just takes a while. Oh, it's done it. So now it's flashed the LED here 3 times. In the code, it flashes it 3 times, and then it says whenever you push the button, the LED comes on. So that tests the inputs and outputs. Let's do something clever. I have got a program. Let me see if I've actually got a recent program here. Nope, I'm going to do it by hand. I'm going to create a program by zooming in for you inside of create a project. It's going to be for a AVR 128. I'm not going to do any more on it. I've selected assembler. Press OK. Type in AVR 128 DA48. That's my part. And here it is. It says I've got an S version as well. That's not a problem. I've got that. Okay, so I've created a program. I've created a project. It exists. The microchip application is now loading all the background. Watch this. Back into my program here that we were looking at. Shut down this. All I'm going to do is press function key F7 and it will open up the assembler for me. And here is the new assembler. It's vast. Control C, copy the whole thing. I am going to replace the sample code inside of here. Press the function key F7. Here is all the assembler. I'm going to build the project. Now, for those who can't see, I really should show you the bottom. It's compiled with 3 warnings, and those 3 warnings are trivials. They just says that something's been redefined. It's the same definition. But look, the important thing is I can debug it. So it says start debugging and break. And it's taking me straight into the program. Now, am I actually debugging the real program on the real chip? I am. I'm using NDebugger. It's connected. So I can now walk that. I could walk that. Is it F11 in here? Yep. Here is the GCBASIC assembler that was written. It's setting the stack register at the moment, calling in its sys. It's setting up the chip at 24 megahertz. You can specify that within GCBASIC, and it's now walking the code. And this is setting up all the ports so that we know the ports are in a particular area. We're now setting up the registers, and this is the main loop, I think. This is the first loop. So let's just run to the cursor. Pause it. We look at Zen mode for a second. The chip is sitting there. Very good. If we look on the screen, we can see that the Z register is changing. We can see that the I/O port, is it C, is set up. And here is the virtual port here, and that bit is changing. Oh, it's down in the loop, is it? It's waiting for me to push the button, isn't it? So we can actually walk the code. Look, we can walk the code. Fantastic. Look, we're walking the code in the debugger using NDebugger. You know, we're static. We are not moving. If I hold down that button, it just set the port on because in the debugger, I selected that code. Look, you can do what you like. It's up to you guys. Back to GCBASIC. It's very simple. You can make extremely simple programs. You can pull them into, you can pull them directly into Microchip Studio, which used to be called something different, hence I installed there. You can create code, enjoy. It should be really good fun. So what I wanted to show you that AVRDx microcontrollers are now supported by GCBASIC. Join the development team. We need improved libraries for these things, absolutely. Yeah, there's going to be issues, absolutely, but the basics are there. Enjoy.